Hello students, welcome to Saurav Sir's classes. This video is a continuation of the exam summary of linear algebra. This is basically part 2 of this video, rather the second video of this series. So we'll start with algebraic multiplicity of an eigenvalue. Now, for an eigenvalue lambda of a given matrix A, algebraic multiplicity is the number of times lambda is a root of the characteristic polynomial of A. So this was the algebraic multiplicity. Next, we come to the geometric multiplicity of an eigenvalue. For an eigenvalue lambda of a given matrix A, geometric multiplicity is nullity of A minus lambda I. This gives us the number of linearly independent eigenvectors corresponding to the eigenvalue lambda. So corresponding to the eigenvalue lambda. Also, there is a direct formula to calculate this, which is nullity of A minus lambda I is equal to number of columns of matrix A minus rank of A minus lambda I. The next important result is that determinant A is equal to product of the eigenvalues and that trace of A is equal to sum of eigenvalues. Next, an n cross n matrix is said to be diagonalizable if and only if its minimal polynomial is product of distinct linear factors and for each eigenvalue AM is equal to GM. A few more results. For any n cross n matrix of rank 1, eigenvalues are 0, 0, 0, n minus 1 times and trace of A. Then another result, an n cross n matrix is invertible if and only if 0 is not an eigenvalue of that matrix.